Hello, everybody. I apologize for being a little late and thank you for waiting. I'm clicking on allow everyone to talk so that you can all chime in and talk and interrupt. There you are.
Well, hi everyone.
Hello. Thank you for greeting everybody and let me give you the link. Okay, and if I missed anybody, please tell me. But the link is right here. I share the screen. So that is my screen. That is what you need here. AI. So I'm giving you that link, I'm giving it to you on chat. Okay, and I welcome everybody to click here because then you will see what we're talking about. Now, an introduction for those people who are here for the first time. It's an overview of what's going on in AI, and the interesting part and the emphasis is on practical implementation. So that's where we are going beyond just chit chat, if I can say so. But I usually show that I tried it and it worked or it didn't work. That's what we will be talking about. And that is the whole story of what we've been talking for more than a year. So today is the 19th of January, and you can see what we are talking about today. And before that, you can see all that we talked about before that. Okay, now I see that there is the first. Yes, if you cannot be here, if you have to hop out, then of course, as I'm reading now the Odyssey, and they say it's very impolite to tell your guests to stay if they don't want to, but you will all get a link. We've been talking more than a year, and you will all get the link of what we spoke about today. You can also find the previous recording. Okay, that's enough. Let us start. One thing that I promised you is this. The first thing, that was the leaderboard. I said I'll find which leaderboard we were talking about, so I'm opening this leaderboard, and that's not the only one. There are multiple, and this is Toloka, and it's talking about that these results come from humans as well as tests. So they're trying to be as objective as they possible can, and as inclusive. Let's look at who is the first. So GPT-4 is the first, and that's very clear, and that will probably be everybody's agreement. But what's amazing to me is that they're not so much far ahead as you would expect. You would expect 10, 20%. No, what are the others? So this is Wizard LM, but that is a relative llama. So we can look up exactly who is who, but it is another, I don't remember is that open, but not all of them are open. So Llama isn't open available. Vicuña is also available. That wizard, I think, is not publicly available for download, but just like ChatGPT. So it's a mix. And in this mix, you see everybody is pretty high. That's amazing. Now, to just make sure that not everybody is there, here's Guanaco, and they are much, much weaker. So that shouldn't deceive you. That tells us that that's pretty high. And what's missing is very important. And what is missing is why is it not 100%? You remember how Google Translate was not as useful, to the point of not really being usable by people when it was 80%. And now it's, I believe, 96. And the difference between almost there and there is tremendous. That's what I wanted to show you first. If you want to go, then there are no links here. You have to research. But all of that is telling us that there are open source alternatives. You can do a local implementation where the data doesn't go away. So if your client or if your friend wants to experiment with something that is deployed locally and he is CGIS compliant or any other kind of compliant, you can do that. So that's one thing that I wanted to show. Another thing is New York Times tells us that they are on the level of human champions in math. It's right here. And more precisely, there are mathematical Olympiads here. And AI competes on the level of Math Olympics. How on the level? Let's go down. This is the team. This is, well, it's almost there. Let's open another. That's more detailed. I want to show you this picture. There you are. So previous state of art is here. Alpha geometry is what they do now. That's 25 solutions out of about 30. So human champions, gold medalists, they get 25.9, and Alpha today does 25. So that is definitely on the level of human performance. And that is great. That's what we should all celebrate. You can read it more in detail. We'll talk about how they did it. But sorry to bring in a little bit of a but, and it is that, look, that's a very specific problem. That's geometry, solving problems on a great level, no doubt. And they talk about it here. And then there's a paper in Nature where they explain it in more detail. But in the end, great though it is, it's solving a very specific problem. And we're now in the age of general artificial intelligence. We are on the age where you have ChatGPT talking about anything and about any language. So compared to that, I would say that that is still very specific, great though it is. Now, one thing I noticed today is that there was an article about Google, how they're firing people, laying people off. Well, supposedly because their DeepMind doesn't do it as well as ChatGPT. Well, with that, and I didn't go deeper into how they do it, so I should mention just a little bit, at least a little bit about how they do it. Okay, what they do is train their model, and it's not an LLM. It's a very specific, large neural network. And this neural network first generates 1 billion examples. So it probably shows it here, how it generates 1 billion, these kinds of things, converts them into text, and then selects, I think, 100 million good solutions. So as you see, it's very specific, similar to chess playing algorithm, but great, but just specific chess. That's what they generate. That's their data set. So they don't use a human-generated data set, but humongous machine-generated. And then they're training their system on that. Okay, let's pause for a second and look at whatever people were saying. Okay, people are happy to connect and collaborate. Paul says, what is the rewrite test? I don't right away know what the rewrite test is. So let me do this. Let me look at what you guys add and maybe put it on the next discussion because I can't adopt or can't digest right away what you're saying. But that's the important thing. Very interesting result, limited though. Now, that is what happened so far. Let's go back. Let's see what's next. That was the alpha. Now, last time somebody asked a question about Dataverse. What is Dataverse? Well, Dataverse is another way to sell AI to you guys. Here, Microsoft shows their thing. And notice, please, that they use multiple terms, multiple keywords for sales. So once in a while, it is called Dataverse. Here. At other times, it's called Power Platform. In my humble opinion, all these times, these are just words. It ends up being connections to the data and AI talking about this data. So maybe we can go deeper, but I'm staying with the open source and showing you what that does. So I hope that was enough of a discussion here about what Dataverse is. Here are the products, and you notice Power BI. In other words, okay, that's another spreadsheet for you. But of course, what's important is that you can connect to any data source. There are copilots that are your own. You can take and make a copilot inside of IntelliJ, let's say, but you can also create your own copilots. Once you are there, once you are within the world of Microsoft, all right, so you can consume all of that. But I will go on right here, and I want to talk about Pinecone serverless. All right, let's see who says what. What was the website again? Now, the word again maybe means what was the leaderboard, or maybe it was just that whole link. So I'm giving you that link again, and I'm giving it to you on chat here. And that is everything. Every link is how found from here. So we talked about different leaderboard, which essentially proved to us that we don't have all the time in the world. We know that ChatGPT works the best. Besides, I just got accepted into enterprise version, and advertisedly it is the beta best, and so on. So I'm staying with this, and I'm doing, as you probably will remember, a lot of different implementations, and all of that are using ChatGPT. That is what's going on with the courses. You remember this is a learning path. Let me quickly go there. These are all the courses. You see 27, almost 27 of them. And the latest being operations on LLM that comes from Google. Before there was LangChain on JavaScript. So lots of interesting things. And Chroma, of course, advanced retrieval. We talked about all of this. I just wanted to show you, wow, that's so much things that are great and they work and they're interesting, and we cover every new thing, which happens almost every week, if not more. That is all technology that there is. But right now, I wanted to show you the Pinecone serverless. That's a new thing, and then also do something practical. So let's see who said what. Okay, thank you. Now I will pause for a second. I'll stop share. And I'll give you a chance, 1 minute chance. Okay, let's continue with more of a practical implementation part. So I'm sharing the screen again and Pinecone serverless, because all of that I would still talk, okay, very important, very high level, but news. Now, Pinecone serverless is news, but a news of a different kind. First of all, we all remember how it works. How it works is you use ChatGPT. You start by taking all of your documents, and that can mean hundreds of thousands or millions, perhaps more documents, and stick them into Pinecone. Pinecone is your database, but really it's not a database, it's a NoSQL database. And even that is not a complete description. Pinecone is a vector database or syntactic search engine. So let's stay there. Let's say that it is a syntactic search engine which allows you to search by meaning, not by keywords, but by meaning. So you take all of your texts and you break them into smaller pieces. For example, a paragraph. Paragraph works well, but we'll talk about what works even better. Let's say you take all the documents, break them into paragraphs, get a few hundred thousands maybe, that depends upon your use case, and that's called a RAG, Retrieval Augmented Generation. Then you ask a question, you say, okay, I'm very interested in, well, legal cases, all of them are what I'm working with legal cases. So you can ask a question like, what did he do? Did he kill somebody? And it will search not by did he kill somebody, but by meaning. That is step number one. Step number two is now that you get back the list of most important, most relevant pieces of documents, then you ask ChatGPT and you're saying, here is what's called the background or the you can call it context. And with this, maybe 10 documents, you are really asking ChatGPT and getting a very reasonable answer. So that is the standard architecture. The one which I just showed you was improved results. How can you do it? That's called with Chroma. But let's leave Chroma aside for now, and let's just do it with this Pinecone. So it works. It already works. It's implemented in many places. You can improve this implementation. For example, one of the ideas is you don't just ask the question, but you also suggest a possible answer. Now you get both the questions and the possible answer, and now you're searching for that. So it is much better than just searching for only the question. Now you're searching for question and answer that's more precise. You get a better answer. That's one of the three ways how this works. Okay, now we come to the Pinecone serverless. So what they say is that, first of all, it is maybe 50 times cheaper. Now, I didn't make a mistake, 50 times cheaper. Why is that? Well, because the normal way of using Pinecone is running it in a virtual machine, one virtual machine, and that is $70 a month. Of course, you can use it a lot for those $70 a month, but that assumes that you do use it a lot. What if you don't? What if that machine, and I have three of them, $70 a month, that's $210 a month, and then mostly of the resources are wasted. So, of course, with that, you think, oh, much better if I put it into serverless. So those instances that are not utilized at all could give you much faster results and much cheaper, and that's the news. So I think it is so important. It's out for 2 days or 3 days, but it's so important that for the next trial, for the next week, I'm going to play with it and show you how it works, and basically just a lambda implementation of the same thing. Just a lambda implementation, but it's a revolution. So we'll find out exactly how it works. And they say that not only the size and the price, but also the fast running. And finally, let's go. Let's log in and look at it. It's Pinecone. It's very easy to do. Here you are. You're logged in. And you just start a new index. And when you start the new index, then the serverless is the first choice. So it is just no-brainer to do it. I only have not done it, but that is a great thing to do next time. All right. So let me look at the what you have saying and chatting about, and then I'll go into practical implementation right now. So do you have any incident pros and cons in various vector DBs, Chrome, Pinecone, Sync, single store? Vlad, it's a great question, and I'm only using Pinecone. But what about the other DBs? I'm sure that they face some competition. So I agree, and let's do this. Let's copy and say vector DB is live, Chroma, Pinecone, and single store, and that will be for the next time. So I'm going there, here, and that will be the next time. So no answer so far, but I promise to do it next time. All right, thank you for that. And we already talked about Pinecone, but now this time we'll do it in practice. So let's put it in real use. Hey, that's one thing that you asked. Another thing was okay, and that link also is interesting. So let us put it there. Too many things to look at, but it will be here. All right, we'll do that. Just can you please an Excel sheet with us too? So I think when you say Excel sheet, you probably mean again the link, because everything is mentioned there, all the links. So let me first give you this link, and I'm giving you the link in chat. So you can see all of the links here. That is the first link, and from there you can go anywhere. And then I see many questions about it. That is great, because I really love that when I see your questions. So Google Doc, that's exactly what I gave you. Yes, there you are. All right, that's wonderful. Okay, now practical things, what we do, and I need to delete them, but it's too long, so I'll just keep them for the future practice. So practically, we do those implementations. What we're doing is exactly implementation, and I'll show you the version of thing that I'm running. It is here. Okay. So I'll show you what's inside. I will show all the inside also. And here it is. I'm running a virtual machine. It runs in two ways. One is that's VNC. VNC allows me to run multiple services here in the operator console, I would say. First of all, there is a running, how do I processing, how do I index all of them? Well, and that is how run. So there is a virtual machine and I can give you it to guys who wants it. Now, the second thing is that's the operator. That one is the result. Right. So that's called free, and that essentially works for everybody who is interested. First of all, here are the cases that are ready to play with it. There are two of them. It's a bunch of documents here. It's a medical documents here. So let's do this one first. First of all, you can search. Now, there is no big deal about searching. Anybody can do it. Here are the, 5 documents, but then you can talk to it. Of course, you can search for Enron, for example. Let's say we'll look at Enron, 3 documents, but really want to talk about this and tell me about Enron people. So again, red. First, we do the implementation, then we can index it in Poncone, but then we're asking questions and it should tell us sense. And that's the answer. Now, the answer is not what we want. It's not exactly what we want. And that's ChatGPT. What we want is to index exactly these documents and then talk about just these documents. For that, you would have to go into VMC, index. Somehow it is not indexed. So let me do this. There is a search for the second one. And that's about medical implementations. So first of all, let's search the documents. There are 37. Each one of them is a certain medical, how would they call it? Journal of American College Board, whatever. And then you want to talk to ChatGPT using all these documents. So let's talk this time. Tell me about colds. Can you tell me about colds? And spelling is not important. It's a little bit slow, but that you can fix easily. But it does talk about the colds, and it now goes with the real, how do they call them? In medical documents. Let's call them medical ending. Okay, so that all is you can imitate it in ChatGPT. Of course, you can take the documents and do it in ChatGPT, but that's only for 36 document. When you're going to big documents and when you want to do something real, real indexing, and then in ChatGPT will not cut it. It won't be enough. So that's where you do this reg in implementation and run with that. Now, that's what I wanted to show, and what it took me, it had a lot of crashes. It also ran fast API with a lot of open connections. I had to kill them, and now I have one script that reloads the system. So it was a lot of work to do, but now it's working pretty well. And that's Good. That is finally working, and very soon I will allow people to run this machine. It will be ready to go. I think I need one more step so that you can not go in there. That's only good for the operator. Now, I want people to see this clean, nice interface. And one thing that I'm working on is drop more data. Right now, ChatGPT gives you the way to drop more data, but it is only doing that. Well, okay, I need to drop more data here, and that means one more tab. So that's one thing. And another thing that I'm showing you is very advanced stuff, but I will still show it. Let's say I'm interested in something very specific. And that something specific is gas chromatography. So gas chromatography, I have a book. Here's my book, gas chromatography. But there are two problems with this book. First of all, it is not readable by ChatGPT. It doesn't get it. I have already put it in. It's a RAG. It's there. But you can try to read it, and it is not understanding things. So what you do is you read it, then you put it into blog. That's the blog. And then it gives you two advantages. First of all, is that you finally put it into small pieces of information that will be just right. And secondly, you also rewrite it because I don't know what will be in the end. Will the ChatGPT be free, or will the New York Times, for example, which has already sued ChatGPT for use of its documents, will it win? So nobody will sue me for that, I hope, because we're rewriting it and well, doing a lot of changes, not on purpose, not to do the changes, but just really to rewrite it. And that will be done a very powerful expert. Right now, if you need to go to court and help the lawyer, well, you need a very smart ChatGPT assistant that will talk about gas chromatography. But with this blog, which will be about 300 to 500 little articles, that will be exactly right, and that will be able to uh, find expert level help in exactly the area. Well, okay, maybe I told you too much, but it is exactly what I'm doing right now. So, done. I told you about this. I will stop sharing and I will look into your questions there, the chat, and the Q&A. And now I will shut myself up for a minute so you will be able to talk. Okay, Sri, sure. I'll give you first of all my LinkedIn. Hey, that's me here, and I'm giving that to you in the chat. Here, that is my link. I already gave you the link to the show, so to say, that is talking about everything that we spoke about so far and today. Okay. And again, I'm going on mute, even going on mute just to stimulate you talk. Okay, stop talking. Nobody wants to chime in, and what I'm offering you is this. You have the link. Let me do it just once more. Just one more. I'm giving you the link where you can find everything that there was and everything that there is, and also everything that will be next week. I think it again.
Hi, Mark.
Yes, please.
I do have a question. I didn't quite get an intro on free EEB. Can you just kind of give me an overview of that?
Be very happy. Thank you for asking these questions. So first of all, FREED is Free Electronic Evidence Discovery. It's a project that's been around for 10 years, and it is at the top when you go for free. Well, it's not so much free as much as it is open source e-discovery. So if you want to look at open source e-discovery, then you see the paid advertisement, and then you see the first natural result. It is freed right here. Okay, so it is an open source solution which does a few things. It's indexes the data and allows you to search. That's about 20 years ago. And then it adds AI. So now that you can do first search and then AI, that's the second step. And the third step is I have created a VM. That VM is run on Amazon for those people who want to play with it. That is as scalable as people want, because it is just stop it and restart it with a new size. And I'm working on yet another engine which will have no limitation on the speed of processing, because if you just do the regular indexing, then it takes 10 gigabytes per hour. That's very small speed, right? So I have a new engine that runs on a cluster, and that reaches up to 1 terabyte an hour, and I practically don't need any more than that.
Actually, I think 10 gigabytes an hour is pretty good for one machine.
It's just a regular VM. Thank you.
Yeah, that's pretty good.
Okay, so that's what it is. Now,
Oh, wait, one more thing.
give it
On that,
to
did you say,
people,
are you
I
saying
ask them to subscribe to a support, $50 a month, but those things, they do take resources. That's current implementation. Yes, Paul, what else?
Yeah. Oh, are you saying that you made an AMI so people can use?
AMI, but people cannot use it by themselves.
Is that, yeah, because you said you can scale
I
it with
have to
the
start
VM.
it for them. It's a lot of setup that I have to do. So yes, it's open source, but practically very few people can start it. So instead, what I do is I start it running. Well, I could maybe give the IAM, but AIM, but not right now. I think when I release it in about a week. So when I release it, when people want a VM, then I'll be giving them that VM.
Okay.
Is that what you asked, right?
Yeah, yeah. I'm very curious as to how you're setting it up.
Well, we'll see, because e-discovery, people pay for the amount of data. So let's say a lawsuit costs you $25,000, and you keep paying for the data. Well, that's a new model. That's a VM, and you pay for the resources, but not for the data. Well, that will be a long story and a long, interesting fight, but that's what it is right now, almost there, running.
Okay, thanks.
Okay, Paul. All right, guys, thank you very much. You're welcome. to ask more questions and mostly write to me. Right? I'll give you the question and answer. And my email is that, so that you can write. Mark@stadia.ai. Right? Other than that, it was a lot, right? And I was going slow and not so polished just because the material itself lends not for very polished explanation. But I managed there, and thank you very much, guys. Be well. Have a great weekend, and we'll talk next time, next week.
Thank you, Mark.
You're very welcome. Thank you, Sridhar. Thank you, Swapnil. Thank you, Vlad. Thank you, Praveen. Saying goodbye.